Okay, today we're going to look at the surface area and volume of cones, so our next geometric shape. We are going to identify the components of a cone, calculate the surface area and volume, and then describe the effects of changing dimensions. All right, so a cone is a circular base connected by a curved lateral surface. It's got a circle on the bottom, it goes up to a point at the top. So the main points and main key features of the cone, since it's a circle bottom, it does have a radius. It has a height, and it has what we call a new piece that is the slant height. Okay, the slant height is the outside edge of that cone. Now, not all cones are perfectly straight up and down with the entire side the same. We also have this idea of this other cone, which is called oblique. All right, that means it's not perfectly straight up and down, that the height does not go through the center of the circle base. Now, in this case, the slant height is going to be this longest side. That is the slant height. All right, and we are going to label it with this little curly L. Because the height goes straight down and makes a right angle with the base, we will also probably need to use the Pythagorean theorem or some PPTs to find either the height or the slant height. Okay, the surface area and volume formulas for a cone. Notice that there is only one base this time. Before, when we had the cylinder, there were two circles, only one base, so only one circle. So it's the area of the base plus the lateral area. So the area of the base is pi r squared, and then that lateral area is pi r times the slant height, L. So pi r squared, area of the base, and the lateral area is pi times the radius times the slant height. The volume formula is 1/3 the area of the base times the height. Notice that the formula for a cylinder for volume is pi r squared h. A cone actually has 1/3 the volume of a full cylinder. All right, so we need to know 1/3 pi r squared. We need to know the r, and we need to know the h, not the lateral height. This is the straight up and down height. Okay, we'll do a couple examples. You can see how to use the formulas. Okay, we're going to do surface area and volume. Let's start with surface area. Surface area formula for a cone is pi r squared plus pi r L. All right, we know our radius is 5, so we can plug that in. Plus pi times 5 times 13. Multiply that through, we get 25 pi plus 65 pi. And add them up, we get 90 pi. And our units on this are inches squared, since this is an area. Okay, volume. Volume is 1/3 pi r squared h And we do have to find the h because we know this side is 13, this side's 5. It does make a PPT, and the height has to be 12. If you did not know that, you could use the Pythagorean theorem to find that out. So the volume is 1/3 pi times 5 squared times 12. It is the height, the total height from top to bottom straight down, not the slant height. So multiplying that out, we get 25 times 12, 300 divided by 3, we get 100 pi, and that is inches cubed now because it's volume. Okay. Example 2. Same general idea. We are going to have to find our slant height by using the Pythagorean theorem. It's not a PPT or anything. So we do that. 7 squared plus 12 squared ends up, and then taking the square root gives us 13.9 for this L. And we got H, and then we have R. So we have our H, we have our L, and we have our R. Those are the three things we need. So surface area, we can plug it in, pi R squared, so 7 squared, plus pi times R, which is 7, times 13.9, which is our L. Multiplying things through, 49 pi plus 97.3 pi. Add them up, we get 146.3 pi. And our since we are using centimeters, our area units are centimeters squared. All right, same idea with volume. Plug it into our formula, 1/3 pi times R, which is 7, squared, times our height, which is 12. So 49 times 12 is 588 divided by 3, or times 1/3, gives us 196 pi centimeters cubed. All right. And our last example, we are going to find the radius and the height. Well, if the radius and the height are doubled in the cone, describe what happens to the volume. So let's find the volume of the original. 1/3 pi, radius is 10, so 10 squared. The height is 18, so times 18. So 100 times 18 is 1800, divided by 3 is 600 pi, and our units are centimeters cubed. Okay, now we're going to double the radius. So now the radius is going to be 20. Double the height. So instead of it being 18, we now have 36. Okay, so we made our cone, we doubled our sides. Let's see what that did to the volume. Plug it into our formula, 1/3 pi times 20 squared times 36. And we end up, when we calculate that through, 14,400 divided by 3 gives me 4,800 pi and centimeters cubed. Okay, now you should notice that it did not double our volume, right? It did way more than double to our volume. Since we doubled the radius and doubled the height, if we look, 4,800 divided by 600, I'll put the pi in there, that equals 8. So doubling our radius and our height actually made our volume 8 times as large. And that's because it ends up giving it a cubic factor. So it made it 2 times, 2 times, 2 times. So the radius and height doubling makes a much larger impact on the volume. All right, you have a worksheet that you can do for this lesson. So get that taken care of, and we'll see you next time.